Hi, I'm Paulina Acevedo, and in this demo, we're going to start off by showing a brief overview of our Fusion HCI system, which is located in an IBM data center in Raleigh, and it is managed by our Red Hat Advanced Cluster Management Console, or ACM for short. And this Fusion HCI cluster is managing a cloud satellite ROCs cluster, which is running Fusion software, and it has Cloud Pak for Data and Data Stage deployed. Then, from the Cloud Satellite ROCs cluster, we're going to do an online backup of Cloud Pak for Data and Data Stage. And this backup is going to be stored in our AWS S3 storage location without any application downtime. And then finally, we will shift over to our AWS ROSA cluster, which has Fusion software-defined storage and is also managed by our Red Hat ACM. And from here, we will restore Cloud Pak for Data. This is the Red Hat Advanced Cluster Management UI, or ACM, where we can see the hybrid cloud topology as it's managing two clusters. So here at the top of the page, we can see the Fusion HCI cluster, which is managing our Cloud Satellite ROCs cluster with Fusion and Cloud Pak for Data. And then at the bottom, we can see our AWS ROSA cluster integrated with Fusion software-defined storage, and this is going to be our target cluster for our backup and restore scenario. From here, we will navigate to the Fusion HCI for a brief overview, and we will launch the OpenShift console UI from this link. From the Red Hat OpenShift console, we will first navigate to Compute and then Nodes, and we can see how this OpenShift cluster is deployed on top of IBM's storage Fusion HCI system. The nodes in the cluster map to the bare metal nodes in the Fusion HCI appliance, and there is no hypervisor layer, just direct and efficient consumption of the server resources within OpenShift. So Fusion HCI melts into how OpenShift is already managed. In addition to compute, the appliance also provides storage for the cluster. We will go to the storage section and select persistent volume claims. By looking at the persistent volume claims, we can see that storage is being provided by Fusion, and resiliency is built into the platform via a resilient storage layer and redundant switches. And we will now take a look at the networking sections, and we can see that the OpenShift network lives on top of the Fusion HCI networking. Fusion is a hyper-converged appliance which is configured and set up out of the box and integrated with OpenShift based on best practices for security and resiliency. We will now take a quick look at the IBM Fusion HCI console and go to the Infrastructure menu and select Dashboard. This dashboard provides an overview and drill-down interfaces into the infrastructure management and storage and data resiliency services. Fusion has built-in Kubernetes operators for hardware management, which removes cumbersome tasks for platform engineering and sysadmin teams like firmware updates or RAS for the hardware. And from this Fusion UI, we can also see how the infrastructure management is displayed. We will navigate to the node section, and from here, we can see key information about the nodes, their status, the CPUs, and memory information for each. And from the network page, we can see useful information about the network. Another key component for Fusion are the services it provides, and this includes the backup and restore service for resiliency of stateful applications. Now we will navigate to the Cloud Satellite section where we can see the hosts or clusters our Fusion HCI cluster is managing. Another key aspect for the design of Fusion is that it aligns with the needs and expectations for cloud-native application patterns. An application-centric experience is critical for removing friction and making the consumption of data services easy and seamless. Data services like backup and restore and disaster recovery are managed on a per-application basis. For the second part of the demo, we will be doing the backup of our Cloud Pak for Data instance along with Data Stage. So here we have transitioned to our OpenShift console for our Cloud Satellite ROCs cluster. We will first go to Installed Operators and then All Projects. And we can see that IBM Cloud Pak for Data is installed on our cluster. And by scrolling down, we can also see the IBM Fusion operator. Next, we will go to the networking section, then routes, and select Cloud Pak for Data, and this will launch the Cloud Pak for Data instance. Now we will navigate to Data Stage Project and we will open the sample Data Stage workflow. So once it opens, we can see it has 4 different databases and several data processes. Next, we go back to the Fusion UI and we will demonstrate how to backup Cloud Pak for Data using Fusion. So we will navigate to the backup section on the left menu to create a backup policy for Cloud Pak for Data. To do so, we're going to click on Add Policy and fill in the policy name. Next, we're going to schedule how often I want this app to be backed up, and I will select weekly on Sundays. And then we will select our AWS S3 bucket, which I had previously added as a backup location. And then lastly, we enter a 7-day retention period for this backup and click on Create Policy. And now we can see the policy was successfully created. Next, I will navigate to the Applications page and assign the backup policy to Cloud Pak for Data. To do this, we scroll down to Cloud Pak for Data and we click on the 3-dot menu on the right and select Assign Backup Policy. Once the menu opens, I select the CPD backup policy and leave the Run Backup Now option selected and then click Assign. We can see now that the policy was successfully assigned, and to view it, we will click on the CPD application and navigate to the Backups menu. By using the Snapshot in Progress filter, we can now see the backup policy is running. Now we will switch to the ACM UI and navigate to the cluster section where we can see both the Fusion HCI cluster and the AWS ROSA cluster, which has Fusion Software Defined Storage deployed. We will select the AWS ROSA cluster, click on Local Cluster, and launch the OCP console by clicking on the URL. Once the link opens, I select Operators from the menu on the left and then go to Installed Operators. And this shows a list of operators which are currently installed on the cluster. We can see that Cloud Pak for Data is not installed, but we can do a search for Fusion and we can see the Fusion operator is installed. Now we're going to continue with the restore. We will use the Fusion Backup and Restore service to bring Cloud Pak for Data and Data Stage to life on our AWS ROSA cluster. To do so, I can use a backup that I placed into the AWS bucket to restore my Cloud Pak for Data and Data Stage instance in this cluster. So first, we're going to Networking and select Routes, and then we will select IBM Spectrum Protect Plus namespace from the project drop-down menu, and we will click on the link to open the Spectrum Fusion Protect Plus UI, or SPP for short. Once the UI loads, we will navigate to System Configuration on the left menu and select Storage, and then Cloud Storage. Here we can see the AWS S3 bucket we had previously added. Then I will navigate to the Jobs and Operations menu on the left and create a job. On the Created Job screen, we select Restore and scroll down to select OpenShift, and we will select our cluster. We then select our Cloud Pak for Data instance and click Next. On the next screen, we select From Copy on the Origin dropdown and On Demand for the type of restore. Next, we select the backup snapshot that we just created and then click Next. On the following screen, we leave the defaults and click Next again. And then we select Restore to an alternate cluster and select the ROSA cluster and click Next. On the following screen, we will leave the defaults and then click Next again. And here on the final screen, we click Submit. We then click on OK on the pop-up window that confirms the backup job has been created. And then we will navigate to the Running Jobs tab, which is in the Jobs and Operations page. Once the restore is complete, we can navigate to the Job History tab and confirm that the restore completed successfully. Now we go back to the OpenShift cluster and we will navigate to Routes and then select CPD from the Project drop-down menu. And we will click on the Cloud Pak for Data instance link. Once the link opens, we will populate the username and password and click on Login. Next, we will navigate to Data Stage Project, and we can see that the workflow that we had before was restored and it still works as expected. So we will click on the workflow and then we will run it by clicking on the Run button at the top, and we can see in the logs below that the project is being executed and everything is working as expected. After a few minutes, we can see that the run completed successfully, and if we go back to the overall project view, we can see the top file, which was created as the output for this run. So this concludes our demo, and we have seen how Fusion Data Protection completely orchestrates restoring the application to a working state on an alternate cluster.